Okay, in this video we will be discussing about the wildcard. We will be understanding what wildcard is, what they do, and what is the purpose of that. And we will also understand this wildcard from the attacker point of view, from the attacker perspective. And we will also discuss how we will use this wildcard feature, this wildcard thing to go from lower privilege to highest privilege on Linux machine. Okay, so without any further delay, let's get started. First of all, we need to understand, before exploiting or doing anything, we need to understand what actually is wildcard and what is the purpose of this. And it is very important to understand because there might be some wildcard related thing that we can exploit to gain higher level privileges, and most people think they know, but in reality they just kind of forget about this, and they missed a golden opportunity for gaining the highest privileges. So a wildcard in Linux is the star character, the star-like thing, the asterisk. When you use the asterisk in a command, the shell replaces it with a list of file names before the command ever runs. So what this means is, let's understand this from the with the example. We have this simple example. I hope you can see that ls and this star asterisk thing. So we type is, we type the L and S, okay, and then we have a space, we type the space, and then we type this asterisk. So the thing is, before ls runs, the ls program runs, which lists the thing for us on Linux, your shell, the shell we are using, the bash shell, the terminal we are on. So before the ls program even runs the bash shell, what the bash shell does is looks at the current directory, okay, and finds every file and folder and replaces the asterisk with their file names. So when you type this asterisk anywhere, what this means is, before even executing this ls program, the bash shell, what the bash shell will do is, it will look in your current directory, look for the file's name and folder name, and replaces those result, the file names and everything with this. So for example, if the current directory contains the file contains some file, like for example file1.txt, file2.txt, and notes.md, and some other files, the shell actually runs like this ls, and these are the files that is present in the current directory. So it means that whenever we see somewhere the static or the star thing in some command or some anywhere, it means instead of this, it will list the current directory files, and uh, it will it will remove itself, and the Linux, the shell will see the file name, all of the file and folder names present in the current directory. So right here you see the ls program never sees the static. By the time the command reaches ls, the command whatever is after the ls, the shell has already done the expansion it is talking about. So this is what the bash shell does. It looks for the current directory, and whatever the files are, it replaces with this. ls just sees a list of file name as its argument. So it ls think like the user has typed the ls and then some file name and like as argument, right? So this exact thing is called glob expansion or pathname expansion. And as I said, the bash shell, the shell does it, not the program itself. This is done by the bash shell, not by the ls program. Even the ls program itself does not know that the user has typed something else, but I'm receiving something else as argument. The program just receives the result, right? So now the thing is, the shell cannot let's read this carefully, okay? The shell cannot tell the difference between a file name that start with a dash and a command line flag that start with a dash. So what this means, and what this is saying, is that, let's say we have a program, and the name or the we have a program or a file or anything, its name starts from some kind of like this dashes, okay, and then we have some another command and another command line flag. What command line flag is, we have software, we have program, we have different program, and each of the program have different flags. Okay, so the simplest example of the command line flag is that we have the netcat tool. You might already know about this. So when we want to start listening, okay, on a specific word, what we do is we type the hyphen and then lv and p. We just type like this and then specify the port. So this right here, this thing is the command line flag. So the bash the shell actually cannot do the difference between if this is a command line flag or this is a file name. When the shell expand this into a list of file name, it produces something like this. As we discussed, this is, for example, file 1, this is file 2, and then this is another file, and then this is another file. So you see right here, this specific one, if a file name this dash dash checkpoint equal to 1 exists in the current directory, it appears in the expansion, the path name expansion. Is it called path name? Oh yeah, it is called path name. So in the path name expansion, just like any other file, like the file 1, file 2, and the rest of the file, the shell puts it in the argument list. So we first of all use any program, like in this case we use the ls program, and then the rest of the stuff that we get, the expansion, the file names that we get, what the shell does is these stuff are like set as argument for this program. And since bash shell cannot, the shell cannot differentiate between a file that started with that its name started with the dash and an actual command line flag. As I said, the shell puts it in argument list, the program receive it, the ls program in this example. Now here is the problem. Program like kind of capture or retrieve their argument by looking for string that start with either one dash or this double and treating them as flag. A program like this star receive dash dash checkpoint equal 1 in its argument list and think a user typed that flag. It has no way to know it came from a file name. So as I said, we have different program and they have flag, and the flag actually start from either the one dash or double dash. So in this case we have a single dash, but there is specific program tar which just deal with the zip file and archive file. So this specific file received, if there is a file name double dash checkpoint equal 1 in the current directory, and the bash just set it as argument list. So the tar program, instead of the ls program, let's take the example of this tar for a moment. So we type the tar and then we then type the asterisk. So the bash will list all of the get all of the file name, and then instead of the asterisk, it will give the it will list the file name to the tar as argument. So when tar receive a file name like this in its argument list and think a user typed that flag, basically tar will think that somebody, a user typed this by its own, but tar does not know it came from a file name. This is actually a file name. So tar has to execute this file and to take some action on this flag, because tar thinks that this is a flag used by a user. Now this is not a bug in tar specifically, because as I said, each program has its own flag, has its own function. So and the flags start from these dashes. This is the fundamental consequence of how Unix argument retrieving work combined with how shell glob expansion work. Many programs are vulnerable to this. So in simple term, it is saying that when you combine the way the argument are being passed to the tool or program, and we combine it with the path name expansion, so it become kind of an exploit, we can say that. And many programs are vulnerable to this, like for example this tar program. Okay, tar is the classic example of this, one of the classic example of this path name expansion, the wildcard exploitation example. Tar is used constantly in backup script and cron jobs, the schedule task. It also happens to have some very specific flags that make it dangerous. So as I said, tar has some specific flag. One is this that we just talked about, this right here, and then we have some other flags as well for the tar specifically. So when tar see this specific flag, what this means is print a progress message every n file is processed. Each of the it means every file is processed, each of the file gets processed. Tar is a tool related to the backups and archiving. So let's say when tar archive a single file, and when we use this flag, it will print a progress message after we get one archive, or the tar program make one archive of any file or a script. And we have another flag which is, instead of default progress message, perform this action at each checkpoint. So after this, after using this, we, instead of like getting the default message, we use this specific another flag and telling the tar to after you process any file, you will have to perform this specific action. So we will here specify our action, what tar has to do after it process a single each file. So like for example, here we specify our action or the whatever we want. We type execute equal command, which means that when tar makes a backup of any file, it actually process one file, it create a backup of any file. And since we specify this flag, we then specify that instead of showing us the default message or default message, perform this action, and the action will be the to execute command after each checkpoint. So the last one is critical one. This exactly, this is one. Tar has a built-in feature to execute arbitrary commands during archiving. This means the tar has some kind of special feature that can execute command during when archiving some kind of file, script, or any file. It was designed for legitimate uses like progress reporting script, but combined with wildcard injection, it becomes a root shell. So I told you about when you combine the how the flags are being used and with the wildcards exploitation stuff, it kind of give you root shell. Now let's move a bit more and see. I don't know if you can see that these are like black, so I'm just gonna go to another place that will be have the same guide, but it will be a bit okay. This is the same guide, and let me scroll to that place. Okay, we were here. So what we will actually be looking for is that this is same thing like finding out about the cron job, the schedule task. We'll type the cat and slash etc slash the cron tab. This command I'm talking about, cat etc slash cron tab. It is like this cron tab. So it will list all of the schedule tasks to us. What we will be looking specifically in that is that we will be looking for a schedule task that is being executed by a root user, and the command that it execute must have this asterisk thing. So specifically we will be looking for some cron job or schedule task that does something like this. Specifically it is using the tar program, and then we also have this wildcard, the asterisk thing. Okay, in this one we also have the tar and this star. So the condition we will have, first of all we will need to find out a cron java schedule task that run as a root user, and then also use some tool that has the built-in feature to run or execute command, and then it must have this asterisk. This is one condition. This is another to must have this asterisk. And another important thing is the wildcard expand files from a directory you can write to. Like it is saying that the file or the command or whatever it is backing up the tar program, we must have the ability to write to that directory. I'm just gonna explain a bit more. You will get clear idea what this all mean. Now as I said, we will type this, or this will get the schedule task. Okay, once we get the schedule task, these are specifically programs that mostly can be used to exploit the wildcard stuff. The tar program, the 7c zip change or change mode, and this rsync program. So I type this specific command and I try to see any cron job or schedule task if it has the any of those listed program and the static, but I did not see in that, so I don't have the vulnerable machine to practice on. So we have these programs, we will be looking for these in the schedule task and also with the static, and where these program are actually writing to, like for example this schedule task, this star program is this creating this. So instead of this, look at this one. Okay, I hope you can see that we have this specific let's take the example of this cron job. So suppose we got this cron job, this schedule task, and it is doing the cd change directory to this, okay, and it is then executing this specific command. The tar program is executing this specific command in this directory, and we also have the static over here. So remember the condition, as I told you, the cron job must run with root, okay, and then it must have any of these toolkits. Most these are the well-known example that we can use with the wildcard exploitation, and then it also has the static. That was also a condition. Another condition was we need to make sure if we can write to this directory or no. So suppose if we can write to this directory, what we will do is, since star is creating the backup in this directory, we will see if we can write to this directory. We will create a file with this specific name, okay. So once we create a file name with this, we are basically telling the tar program to give us some output, some message once you create the backup. So we then create another file, okay, with this flag, and then we tell and we name the file like this. So instead of tar giving us default message, we tell the tar to execute this action. So what this action is, it will this is the same thing. We tell the tar to perform some action, and the action is execute this specific script, okay. And we also need to put this script in the same directory, in this directory. So we will then create the third file we will be creating is this file, since we specify to once you process each file, perform this specific function, and this is to execute this file, this script actually. So we need to place it as well, this script, or otherwise we need to specify the path, and this is actually our malicious payload. So since the cron job run as root, it will also execute this exploit.sh as root. When tar runs and expand this wildcard, it picks up all these three file name. It reads the first two as flag, these two, okay, because they start with this. As I told you, this is how the tar program takes the flags. Those flags tell it to execute exploit.sh, this specific third file. At each checkpoint, like the tar program process one file, it execute this. The tar program process another file, it will do the same thing for this. It will then also execute it second time. Since tar is running as root, exploit sh run as root as well. That's what I told you. So we need to check if we can write to that. We will move to that directory, okay, because this is where the tar program is creating the backup. We will then create a file with this specific name, okay. This is the same thing that we just talked about. It is like creating a file with this name, and inside that there will be nothing. We are using echo and creating the file. I hope you know that. And then another file, we also create another file with this specific name, okay. So we created two files in this directory. The third thing we do is we also need to create the exploit.sh. So we'll then create exploit.sh file, and then type the stuff in it, either by using the nano program or just using the echo. So this will use the bash shell, and then this is our payload. What this will do once the sh script gets executed is that it will basically copy the bash shell file, the binary of bash, to our temporary directory, okay. And then on that bash file binary that we just copy to temporary, it will enable the SUID bit on this bash. Since this will execute as root, it will enable the SUID as root. So meaning if a normal user run this, it will instead run as root. This is similar thing like the way we change the password of our normal user. I have already explained that. I hope you have some idea about this. And then we also make sure to make this script as executable, because this will look, this second flag will look for this script, and if this is not executable, it will not do anything. So this is the same thing, and this SUID is enabled on this, and whoever run it, it will run with the root, and only if you use the p flag with it, like you will type the slash tmp slash bash and then the hyphen p. This p, I'm just gonna explain what this means. So overall what this means, this was method one of like taking advantage of this wildcard thing. This is just to get root shell on the compromised machine directory, and then we have the reverse shell just to get the reverse shell on to our attacker machine. We will just do something like this. We will in just we need to do the changes in the exploit sh and put our attacker machine ip and then start listening over there. So this is what it is saying. Okay, this is like the proper flow of this cron trigger the job, the schedule task, and shall run when this task gets executed, the shell will run this specific command, okay, to create the backup of this specific backup.tar. And since there is the wildcard, it will expand and kind of instead of this, it will get the file names, the all of the file name that is present in this directory. So it will instead of this, it will look like this. These are the same stuff, and then these are the file names you see right here. This is it, this is the second flag, and this is the actual exploit, and this is some other files. So what tar will see is, tar program will see is it will think that the user is trying to use this flag to create the backup. It will create the archive, okay, at this specific path, and then this is our second checkpoint. This is the second flag. It will then do the process message or give us the message, and this is the specified message we are telling tar to execute instead of default one. So this is just to execute the script. So tar execute the sh exploit.sh script, and this script run as root because tar is running as root using the schedule task. And what this does is it copies the bash binary and sets the uid as root. So whenever we run that, we will, so this is the thing that I was telling you. We got the copy, the SUID is enabled as root. We then type the hyphen p. Hyphen p specifically mean we will be using this must privileged mode. Keep the effective ID, the one that the root ID actually. So let's say if we don't use the hyphen p, even if the SUID is enabled by the root, what this gonna do is bash will detect that your real ID and effective ID is different, and because of that I mean you will be a regular user, a normal user, and the effective ID will be 0 because this the SUID is enabled by root. So bash will detect these both are different, so bash will drop the privilege and as a safety measure and just give you a normal bash. So this hyphen p just kind of disable the safety measure and keep the root effective id. Even if when we use this the bash, then don't care if the effective id and the uid is different or no. So after that, when we type the id command, we will you see our uid will be a normal user, but our effective id will be 0. This is how it works, and these are other program other than tar, and it is specifically saying how you can exploit them. The rsync program, the zip program, and then the other program as well. So hope you get the idea of this. This was very important. I needed to discuss this. If you have any question, let me know. I will make sure to answer you. I will have done the practical, but I did not find any labs, any exploitable vulnerable lab to specifically to this attack. But if I find, I will make a video and then give the reference to this video. So I will see you in the next video. See you soon.